In this lesson, I will be teaching addition and subtraction of fractions. In order to add or subtract fractions, the denominator must be the same. When adding fractions, the LCM of denominators, we use the LCM of denominators to create equivalent fractions, add the numerators, and keep the denominator. Now, what do I mean by that? Let's use the first one as an example. We already learned the LCM in the last video. If we write out the LCM for 3 and 2, we have 3, 6, 9, 12. Here we have 2, 4, 6, 8, 10, 12. Now I'm not going to pick 12 because the least common multiple is actually 6. Now what this means is both denominators could be 6's. So that's what I'm going to do. I'm going to turn the 3 and the 2 into 6's. How do you do that? Well, to turn a 2 into 6, you have to multiply by 3. 1, 2, 3. So multiply this by 3 and this by 3. You're making them equivalent fractions. So this should still be a half, because if you're multiplying by 3 over 3, it's like you're multiplying by 1. You're not really doing anything to the fraction. And similarly, the same thing is done here. 2 times 3 is 6. So we have, let's see where I can write it. Number 1, 2 over 6 plus 3 over 6 is 5 over 6. And number 2, same process. The only thing is now you have negatives to deal with. Now you're still using the same rule for addition and addition that you used in adding positive integers. This is just fractions. So when you're adding numerators, you're just adding the integers of the numerators, and you keep the denominator the same. So let's make them the same number. What's the LCM of 3 and 4? We should get 12. So I multiply by 4 here and 4 here to get 12. And here by 3 and here by 3. So I get negative 16 over 12 plus negative 21 over 12. And this should become negative 37 over 12. Can I reduce this? No. So that's the answer, negative 37 over 12. Well, let's work with this one. Now you see here, this is a 9 and this is a 3. The LCM of 9 and 3 is 9. So I don't really have to do anything to the 9 because it's already a 9. But here I'm going to have to change it to a 9 by multiplying by 3. So this becomes 4 over 9 minus negative 21 over 9. Now keep change because this is subtraction. You change to addition problem. Now what's 4 9s plus 21 over 9? 25 over 9. And that's it. Number 4 is going to be a little work. But the first thing you should always do is turn a mixed number into an improper fraction. So that's what we're going to do. Multiply, add. Now don't touch the negative. Negative is just there. It's just a sign. You're not going to multiply negative 7 times 3 plus 1. You're going to multiply positive 7 times 3 plus 1 to convert it into an improper fraction. So 7 times 3 is 21 plus 2 is 22 over 3. Right? This should be, if we were to rewrite this, it would be 7 plus 1/3, which is 22 over 3. So this is actually negative 22 over 3. And the sign just comes down. We just converted this into a proper fraction, then we just add the sign. 2 times 4 is 8. 8 plus 1 is 9. So this is 9 over 4. And again, don't touch the negative. 1 times 5 is 5. 5 plus 1 is 6. Minus 6 over 5. Now we need to know the LCD of 3, 4, and 5. Well, if we write them out, it looks like the answer will have to be 60. Yeah, the answer will have to be 60. Right, because 3, 4, 5 are relatively prime. right? 3 is just 3 to the first. 4 is just 2 squared. And 5 is just 1. It's 5 to the 1. Because these are the prime numbers. So, as you can see, this one has 2 to the 0 and 5 to the 0. Nothing in common. 3 to the 0, 5 to the 0. Nothing in common with this one. 2 to the 0, 3 to the 0. So when you do LCM, you take the greatest, which is just this. So the LCM is actually just 3 to the first times 2 squared times 5 to the first, which is just 60. That's where it comes in handy when you're dealing with 3 numbers. Now, what do I multiply by 3 to get 60? Well, that's 20. So 20 times negative 22 over 3 plus, here I have to multiply by 15. 9 times 15 over 15 times 4. This is a minus. And here you have to multiply by 12 in order to make this a 60. So 20 times negative 22 is negative 440. Nine times 15 is 135 over 60 minus 72 over 60. So we do our addition rules 2 at a time. Let's do these 2 first. This is negative, this is positive, so take the bigger minus the smaller. So let's do that on the side. 440 minus 135. This is a 10, 9. Wait, I'm sorry. It's supposed to be a 3. Right? So 10 minus 5 is 5. This is 0. This is 305. So 305. Which sign is bigger? We look at the 440 because that's a bigger number. It's negative, so this is actually negative 305 over 60 minus 72 over 60. Remember, so keep, change. This is supposed to be a positive, so let's change it. Now it's going to be negative 305 over 60. Keep this, change. And then since they're the same sign, we just combine them. 305 plus 72 should be 377 over 60, still negative. Now we want to know, is it reduced? Is there anything else that's going to go into 377 and 60? Well, remember, how do we make 60? We made it by 2 squared, 3, and 5. So we have to test to see if 377 is divisible by 2. Well, it's not even, so there's no way. What about 3? 14, 17, it's not divisible. And it's definitely not divisible by 5. So this is actually not going to simplify, and this would be the answer. And for those of you who don't know, there are some ways that you can check to see if a number goes into another number. It's called the divisibility test. So there's a lot of uses for prime numbers. So for 2, to test if it's divisible by 2, the number has to end with an even number. That's straightforward. For 3, the sum of the digits has to add up to 3. Has to not add up to 3. It can be divided by 3. And for 5, just end with 0 or 5. Which makes sense. So what I did was, if you take the number 377, 7 is not an even number, so not divisible by 2. Right? Does not end with a 0 or 5, so not divisible by 5. And if we take 7 plus 7 plus 3, that's 17. 17 is not divisible by 3, so not divisible by 3. So 377 is not, it is relatively prime to 60. So we can't reduce. Now you're not gonna have to write that. It's just, I'm just writing this. Meaning it's in simplest form already. Now, if you want to apply these disability tests, we already know that 18 is divisible by 3. What's 1 plus 8? 1 plus 8 is 9. Is 9 divisible by 3? Yes. Let's try a harder number. 72. I know 72 is 7 plus 2 is 9. Is 72 divisible by 9? Yes, because 9 can be divided by 3. What about 51? Well, 5 plus 1 is 6. And 6 is divisible by 1, so 3 divides 51. And these divisibility tests help save a lot of time when simplifying, especially if you think of them as prime numbers. Well, that's it for today, and this is how you add and subtract fractions, as well as an extra lesson on divisibility test.